In this session, we are going to talk about how logging works in Nerdio for Azure. We'll look at management and tasks and go deep into the caching functionality in the product, including things like intelligent caching and caching of shared mailboxes. Enjoy the session.
The first thing I want to cover today are logs and how to look at logs, how to view errors, where things are stored, etc. So let's start there. We spent some time the other day talking about the various roles in Nerdio. Hopefully everyone has watched that video. But just to remind, quick reminder, we are currently logged in as a partner administrator that has the ability to add new accounts and manage existing customer accounts. And logging is aggregated according to the role. So there is a logs menu here on the navigation on the left-hand side. There are 3 types of logs available at the partner admin level: provisioning, management, and desktop logins. And that's going to be an aggregation of all of the accounts that are visible or that are assigned to that particular partner admin account. So if we go under provisioning tasks, we should see the various provisioning tasks that are relevant to this particular partner account. And then we can search provisioning tasks by account ID or by the type of job. So for instance, if we search for 5009, we should see here's when the 5009 was provisioned. If we search for provisioning, then we should be able to find all the provisioning jobs for the 3 accounts that are in the scope of this particular user. Okay, so I think that's pretty simple. Then you have the same thing going on with management tasks, and we'll talk about those in a lot of detail briefly. And then desktop login, similar story. We have desktop login information that is date filtered. So for instance, if we wanted to see all the logins in December, we would look at it like this, and it will show me logins from all the various accounts. If I wanted to narrow this down to a particular account, then obviously I would just do it like that, okay? So again, pretty simple stuff. Okay, so now let's log into account 5009 and take a look at management tasks. Again, provisioning tasks and desktop logs. One thing under provisioning tasks, there's a little button here that actually expands the subtasks. There isn't much additional detail available from here. And then the time started is when the task started. So basically the time started of the task and the time started of the subsequent task minus the time started of the previous task gives you how long this took, right? So as soon as this one is done, this one starts, so we know this one took 5 minutes. Okay, desktop logins, again, not much here. We can filter by username, by account ID, by date, or by the description, which is generally the host or the collection or the VDI machine that the user logs into. So that's what desktop logins are. Desktop logins are pulled in from the SMS passcode database. Every authentication for a desktop login, whether it's VDI, RDS session host, or an RDS collection, triggers an event inside of the SMS passcode database, whether or not that user has 2-factor authentication enabled. So even if they don't have it enabled, what will happen is that they're going to go through that database and the desktop login will be pulled from that database. All right, let's take a look at management tasks. Management tasks is where most of the activity is. So here you can see all the various tasks that have been done. You can see who triggered them. So the user that triggered them is listed in this column. You can see what the task was, a description of the task, a category by which you can sort. Then you can obviously filter by date. You can filter by status, complete, in progress, pending, or an error task. And then you can also filter by individual users, descriptions, kind of more of a free search type of way to limit it. So if I wanted to look, for instance, for anything that was done by Nerdio, admin at nerdio.com, I would do it like that, and here are all the tasks that that user did. Okay, in addition, we have these two columns on the left that are useful sometimes. When the task is complete, there obviously shouldn't be anything under errors, so clicking on errors was going to be empty. The message generally is success for any task that is complete. For any task that is pending or in progress, again, also there won't be much useful information under message or error. Those are going to be empty for the most part, and there should be no pending tasks now either. The error tasks is when this comes in handy. So these are the two different places when and where error can show up. So there's two types of errors. Sometimes when you click on the message, it will just tell you an error has occurred, which means there's likely going to be more detail under the errors tab or under the errors link. So if we click here, it's actually going to give us the underlying error that generated that process. So, again, in this case, process cannot process command because one of the more missing mandatory parameters. Again, not sure exactly what this one was all about, but you can see more detail under errors. Sometimes when you perform a task in NAP, there will be a little I next to the error right here. So instead of a checkbox, it's going to say error, and there's going to be a little tooltip, a letter I that you can mouse over, and it's going to give you a message. For example, some very common situations will get an I next to them. For instance, if someone tries to add a user and that user already exists in Azure AD, by default, NAP will do the validation to make sure that it's not going to conflict. And then it's going to error out, but it's going to have a little I that you can mouse over, and it will tell you what the error message is. It's a pre-programmed error message to make things easier for the administrator. In many cases, it's not kind of an expected error message, maybe not a validation, but something that failed on the back end. Maybe Azure timed out, maybe something in Active Directory didn't respond as expected, in which case it's just going to say error without the little I. But always going to management tasks and looking at error states here will allow you to view the error message. So the I error message is going to be under view, and then anything else that just says error has occurred, that's a generic message, is going to be under the error pop-up, so you can see what's happening. Okay. Couple other things about the management tasks. What you're seeing here are tasks that were triggered either by users or by things like autoscale. Okay, again, it will have no username, which means it was triggered by the system. In this case, it was triggered by autoscale, and there's no user associated with it. Now, there's a whole bunch of other tasks that we're not seeing here, things that run in the background. And the way you can unhide them is by clicking on this little settings gear on top and say display automated tasks. And this will reset itself every time that you refresh the page. So always make sure to turn it on. It's always off by default. And what this does is it unhides the various tasks that run on a schedule. There are a number of, sort of background refreshes that happen in the system, and we'll talk about some of these caches when we talk about users and groups and Active Directory. But there are tasks that run in the background that are not visible by default just because they would otherwise just be appearing in the list too often, and there's no reason for an administrator to see them. But if you want to see what's going on, you would just unhide them and then look at them. If there is an error, you can click on the errors link and see exactly what caused that task to fail. Okay. Let me mention a couple of other things about pending and in progress. There are two categories. So the entire NAP concept, for the most part, I would say 90% plus, every action you do in NAP gets submitted as a task to be executed asynchronously, right? So when you create a new user, it's actually going to package that request up and is going to submit it as a task, and that task will go in and go into Active Directory, go into Azure AD, go into RDS, and do everything as part of that task. And you can track it under management tasks, what the status is, what it's doing right now. There are certain tasks that are blocking and certain tasks that are not blocking. For example, if you are adding a user, then, and that task is in progress, that means you will not be able to perform any other actions on that user object while that task is running, right? So that kind of makes sense. And sometimes when there is a UI component involved, we actually block the UI component. So if I were to go in here and I would say, I don't know, let's say reset, let's do resets RDS session on this one. They say confirm, right? So it actually locks this UI component while this task starts out as pending, and when it gets picked up, it goes into in progress. See, it got picked up, or it will get picked up in a second. It will go to in progress, and then only when it's complete does the row get unlocked. However, there are certain tasks that don't have a UI component associated with them, and when they go into either pending or in progress status, until they're done, certain other things can't happen. An example would be if there is an Active Directory cache refresh that's running in the background, then when new users are added, those new users cannot be completed. You know, that task cannot run until the AD cache update process is done. So therefore, a lot of times people will ask, hey, I submitted this thing and it's taking, you know, very long time to run. It could be that the task itself is taking a while to run, but that's pretty unlikely. Usually, once something starts, it's sort of consistent of how long it takes, right? If you do a password reset, then it normally takes 1 to 2 minutes, and in this case, it's taking 10 minutes. It's not that the password reset task is taking 10 minutes. It's likely that there is something else running that's preventing that task from starting, and it's sitting in pending status, okay? And the way you would check for that is you would go under logs, you would go under management tasks, you would say, show me everything that's currently in progress. And by looking at this list, you would see, okay, I see something else is running, and whatever else I submitted to happen must be dependent on it, which is why it hasn't started yet. Now, a lot of times you won't see anything here, and you'll have to go up here and unhide the task and see maybe it's one of the background scheduled tasks that are currently in progress, and they are blocking the execution of something else. So again, whenever something takes longer than expected, look for blocking tasks that may be happening at the same time, preventing whatever it is you're trying to do from moving forward. Then let's talk about caches and such. So the way NAP is designed, it's really an aggregation of a bunch of metadata from other systems. So for instance, when you go to the users page, you will see that at the top of the users field, there is a date stamp, right? And this is the date stamp of the user list that you're seeing here. This user list is stored in the SQL database that the NAP is running on top of, and it has information about everything related to the users. Obviously, you know, the username and licensing information and desktop assignment and whether the account is locked or unlocked, what group membership it's a part of. It also, you know, has information about mailboxes, who's forwarding to it, who it's forwarding to, everything about that user object is stored in the database. Now, the information does not come from NAP, right? It pulls that information in from somewhere else. But if we were to do a on-demand refresh of that information, every time you open the user screen, you can imagine it will take multiple minutes, and depending on the number of users, it could be even longer than that. Every time you click on users, if you were pulling up the live data from all the various systems, and kind of correlating and putting it all together and then displaying it, it will take a very long time. So primarily for performance reasons, we decided that we are going to be caching this data in a database. So when you click on the users list, it's actually querying a local database that has a cache of that data. The date of that cache is listed up here. And then this cache gets updated under certain conditions. Number one, if no one is doing anything in the system, it gets updated every 3 hours. And that's what these automated tasks are. So you'll see automated tasks such as, let's look at a few. So you have something called update performance monitoring data, submit auto scale schedule, refresh security settings, update security score, update share mailboxes, update Active Directories, account statistics. So every part of the system that you'll see has a date stamp has an associated background scheduled task that runs on a regular basis, typically once every 3 hours, some of them every hour. We have some intelligence that if, let's say, your cache is more than X, and let's say more than an hour long, and you come to the home page, it will be smart enough to start refreshing for you automatically. So there's all kinds of algorithms in the back that figure out when to update it. But the important thing to remember is you're almost always looking at the cached data, not live data. So again, scheduled task is one thing that updates the cache. The other thing that updates the cache is anytime you modify anything that the cache contains. So for instance, if I were to go in here and change the name of the user, what would happen is this change would be submitted to Active Directory right away. So it would be a real-time modification, but then the NAP would automatically trigger a refresh of that information to actually reflect it when the user list comes up. So any changes inside of NAP will intelligently refresh the cache when those changes are made, okay? So why am I telling you all this? The reason I'm telling you this is that if a change occurs outside of NAP, and it hasn't been long enough for the NAP to automatically refresh the cache on a scheduled basis, the change won't be reflected in the screen. What are some examples? An example is we have this account lockout setting. So you have this button, you can actually click unlock user, it will unlock the user. A red icon with a closed lock will indicate the user is locked versus this gray one indicates the user is unlocked. Now, what if a user actually goes into AD right now and just hits the password too many times incorrectly and it gets locked? Will the NAP know about it right away? And the answer is it will not, right? So if you go in immediately into the NAP, you will not see that the user is locked until the list refreshes, which it looks like it's refreshing right now, which can again happen on a scheduled basis, or you can click the refresh button, which is these spinning arrows right here. You can come into the screen, hit the spinning arrows, that will refresh the cache. The new date and timestamp will show up, and then the latest status of that user will then be updated. Also, if someone goes into Active Directory on the DC01 and makes changes, let's say to the Active Directory username, or maybe someone goes into Office 365 and removes the Office license, all of that will be pulled into the NAP, but only when the cache refreshes. So, okay, so right now let's illustrate this. You have a refresh process running. We go under management tasks, and you see nothing is in progress. Let's do in progress, see nothing is running, but if we unhide these tasks, you can see that there is that thing that just started. And it looks like it was started by the system rather than manually kicked off by a specific user, because otherwise there would be a username in this field right here. So users, groups, shared mailboxes, performance statistics, licensing and login data, all of those things are cached. How can you know? Whenever there's a date stamp at the top of the section and the refresh button somewhere, that means that information is cached. Some information is not. So how do we decide what information to cache and what information not to cache? Remember, the goal of caching was primarily to improve performance and responsiveness. So for screens that either don't take a long time to refresh or are seldom used, they're kind of not used on a regular basis, where a few extra seconds to pull the real-time information is not a big deal, we decided to leave those as real-time. So servers is an example of such a screen. So when you click on servers, what's actually happening here is we're pulling real-time information via Azure API. That's why this is taking a few seconds. You will see this will update in just a little bit, and you'll see the status of each server, whether the server is stopped or running. And then you can also tell that there isn't a date stamp next to the server. Okay. Usually it doesn't take that long. Let's go there again, see what happens. Interesting. So let's give this a few seconds to see that come up. This section right here, we haven't spoken about RDS collections in depth yet. We'll have a whole session on it. But this status and all of these little spinning arrows will take a while. Those take probably a good minute, if not more, because in addition to just pulling up the status of each individual VM inside, this is pulling in the information about who's logged in, on which server, whether the user is active or disconnected or inactive, etc. So this one is intentionally sort of refreshing for a while. So you'll see this is going to continue running, even though all of these guys are now pulled in. The reason it took a while is most likely because of this one. The status here, when it's green like that, means that it's on. If it's the same icon but it's red, it means that it's off. When it's in triangle like this, either it couldn't pull in the status from Azure successfully, or the status of the VM is that it's stopped through the operating system, but it's still not deallocated in Azure, so you're still continuing to be charged for it. Okay, networking is a similar thing. So if we go under firewall, this is not cached information. This is going to be real time. So interacting in the firewall and the VPN and the backup screen, most of those are real time because they're not used, that often, not on a daily basis. It's only something you do when you set it up initially. So again, see, there's no date stamp. There's no refresh button. The way you would refresh it is just reload the page, and then you see all the information in real time. So any changes made to the firewall in Azure directly, as soon as I go to the firewall screen in NAP, will appear immediately rather than waiting for that refresh interval. Shared mailboxes are also cached. And some of the things that we'll talk about on the user's configuration is you can do things like forward email or monitor email, and the NAP will actually show you like a little arrow that you can mouse over and you can see who's monitoring a particular user's email. So in order to get all of that information, you can imagine, so like if Andy IT admin is monitoring some other user's email, the NAP has to pull in all the mailboxes, all the forwarding rules or email permission assignments, and then basically figure out who's got access to whom. So that's why, like, in order for that arrow to show up, the NAP needs to pull in the list of everything that's involved in displaying that information. So in large environments, for instance, the mailbox information is the thing that takes the longest. We specifically split it out into a separate task and we made it non-blocking, because in large environments with hundreds of users, it could take half an hour, it could take an hour to pull in all of the Exchange Online information and then correlate it all and figure out who's got access to whose mailbox. And we don't want that to be blocking any other activities from happening, whereas initially it was actually doing that, right? So whenever someone reports, hey, I did something very simple and it took longer than anticipated to run, we do a root cause analysis to figure out, okay, what was running at the same time and whether that which was running was justifiably blocking other things or whether it could run in parallel with other things.